mineral deposit in Arizona. The earliest miners in what is now Arizona were Native Americans who chiefly mined surface outcrops of salt, clays, hematite, quartz, obsidian, stone, turquoise, and coal. In the late 1600s, Spanish explorers hunted for metallic deposits with a special interest in gold and silver. Antonio de Espejo made the first major silver discovery south of the San Francisco Peaks in May 1583, near what some believe is present-day Jerome, Arizona. By the late 17th century, Spanish prospectors had engaged in extensive mining in the mountains bordering the Santa Cruz River and its tributary Sonoyta Creek. Rare discoveries of sheets or planches of silver, one sheet reportedly weighted 2,700 pounds, fired the imaginations of several generations of miners. Image to left, early-day miners stand in front of a mine portal near Morenci, Arizona. In 1854, in Ajo, Arizona, the Arizona Mining and Trading Company launched the modern era of hard rock mining. A burgeoning mining industry stimulated early growth in the Arizona Territory, and by 1864 nearly 25% of the male, non-native populace was prospectors. By the 1870s a plethora of hard rock mines were yielding prodigious volumes of copper, lead, zinc, silver, and gold ore. In 1912, the newly christened state of Arizona supported 445 active mines, 72 concentrating facilities, and 11 smelters with a gross value of nearly $67 million, equivalent to $1.4 billion in 2006 dollars. The important metallic commodities of Arizona, listed in order of decreasing value, include copper, gold, silver, molybdenum, and lead. Non-metallic, industrial, minerals produced, listed in order of decreasing value, include sand and gravel, crushed stone, clay, cement, gypsum, lime, perlite, pumice, and salt. Arizona's is world famous for its turquoise, peridot, petrified wood, azurite, and malachite. Turquoise, azurite, and malachite are copper-bearing minerals. Arizona also produces energy resources such as coal and small quantities of petroleum and natural gas. Mining districts in Arizona are categorized by the specific geologic environment in which the mineral deposit formed. See the accompanying mineral resource map. Base and precious metal mining districts are classified by the dollar value of metals produced. Only those metallic mining districts with total reported values greater than $500,000, based on 1996 metal prices, in the production of copper, lead, zinc, gold, or silver are shown. Manganese, uranium, and tungsten districts have had significant production. Iron and mercury mineral districts yielded minor quantities. Locations of economically or historically significant mines appear on the mineral resource map. A northwest-trending belt of metallic mineralization across the state is a striking feature on the map. The southeastern part of this belt is dominated by porphyry copper, red on map, and associated lead, zinc, gold, and silver deposits, blue and purple on map. These deposits are largely associated with granitic rocks intruded 70 to 55 million years, MY, ago. A number of important deposits in central Arizona are associated with Precambrian, 1,750 to 1,650 MY ago, volcanic rocks. The western end of the belt is dominated by gold deposits, orange on map, mostly related to volcanic activity between 25 and 15 MY ago. In addition, economically significant uranium deposits, light blue on map, are concentrated in northeastern Arizona. Locations from which a commodity has been produced are designated by stars. Arizona is believed to have potential for undiscovered metallic, non-metallic, and other resources, including oil and gas, coalbed methane, helium, carbon dioxide, and geothermal. Copper remains Arizona's most abundant and valuable metallic mineral product. In 2017, Arizona provided 68% of domestic copper production in the U.S. Arizona has two major types of copper deposits, porphyry copper in southern and central Arizona, and the volcanogenic massive sulfide copper of the United Verde mine in Jerome of central Arizona. A third copper source includes copper of breccia pipes of the Breccia Pipe province of northern Arizona. Most of the copper mined in Arizona comes from porphyry copper deposits. These are copper ore deposits associated with intrusive igneous rocks similar to granite. Porphyry describes the typical texture of these rocks, in which individual mineral grains about 1/10 to 1/2 inch in size are surrounded by smaller grains that are barely visible to the naked eye. These deposits, formed from saline, metal-bearing fluids expelled from cooling magma. Interaction of the fluid with heated groundwater yields a corrosive liquid that chemically alters rocks adjacent to the intrusion. Porphyry copper deposits commonly yield molybdenum and silver as co-products. The intrusive activity responsible for Arizona's porphyry copper deposits occurred about 70 million years ago, in the Earth's crust deep below the ground surface. The rich metal deposits were subsequently exposed millions of years later by faulting and erosion. Weathering processes, which accompany uplift and erosion, further concentrated the copper. This secondary enrichment occurred when pyrite, iron sulfide, oxidized, dissolved in rainwater, and formed an acidic iron sulfate solution that dissolved the main copper ore mineral, chalcopyrite, copper iron sulfide. The dissolved copper was redeposited, principally as the mineral chalcocite, copper sulfide. Bacteria may play an important role in both the dissolution and reposition of the copper. A second major type of copper deposit in Arizona formed in Precambrian age volcanic rocks such as those in the United Verde mine at Jerome. Hot, metal-bearing liquids emerged from springs associated with ancient submarine volcanoes. When this liquid mixed with cold sea water, metallic minerals came out of solution as tiny particles that fell to the sea floor. If a metal-rich hot spring was active for a long time, a thick layer of metal-rich mud accumulated around the spring. These deposits contained copper, lead, zinc, silver, and gold. Modern black smokers, hot springs along seafloor spreading centers, are small-scale analogs of these ancient deposits. Gold glitters. But in Arizona, it's the industrial minerals that shine, to the tune of $450 million in 2017, source, USGS Mineral Commodities 2018. If copper is the thoroughbred of the Arizona mineral industry, industrial minerals are surely the workhorse. The sand, gravel, and broken and splintered rock that mantle Arizona basins, collectively referred to as aggregate, are a mineral bonanza. Every building activity, from homes to skyscrapers, from roads to bridges, and from dams to power plants require these natural stone and mineral products. Of the more than 300 active mines in Arizona in 2016, most involve quarrying industrial minerals. And as frequently as not, it's the geologic maps and reports of the Arizona Geological Survey, AZGS, that sheds first light on these valuable rock products. Exploration geologists pore over our surficial geologic maps for evidence of economic mineral deposits. Check out some of our publications below. In no particular order, Arizona's industrial minerals include limestone, dolostone, sand, specialty sands, gravel, clays, bentonite, pumice and pumisite, perlite, diatomite, kyanite, zeolites, peridot, salt, potash, quartz sands, gypsum, talc, and crushed stone, marble, granite, quartzite, basalt and cinders, among others. Products manufactured with Arizona's industrial minerals are legion: concrete, brick, veneer stone, glass and ceramics, tiles, putty and caulking, toothpaste, jewelry, from semi-precious stones kitty litter, roofing shingles, planes, trains and automobiles, asphalt, plastics, optical fibers, drilling fluids, wallboard, pencils and papers, just to name a few.